Okay, all right. So, grade 8. This is chapter 3.2 on the Pythagorean relationship. This is starting at question 4. It says, what are the areas of the square shown? So the reason why this is a question anyway is because this is a right triangle, because it says so right here. It says it's a 90-degree angle. So because it's a 90-degree angle, and because it's a right triangle, what we have learned so far is that all right triangles have a specific ratio that they have, and that would be that the area of the squares attached to the legs of a right triangle will always equal the area of the square. So we call this A, and we call this B, and we call this C. C would be the longest side of a right triangle. We call that the hypotenuse. And A and B are the two sides of a right triangle that make up the 90-degree angle, and we call those the legs. So if this is leg A, then the area of the square attached to that leg would have an area of A squared because it's a square. The second one with a side length of B would have an area of B squared because it's a square. And the square attached to this third one, the hypotenuse, would have an area of C squared. And what we learned is that if you take that A and square it and you add it to B squared, or the area of the two squares attached to the legs of a right triangle, will always add up to be the area of the square attached to its hypotenuse. So in this case, it says E, instead of being a nice number, it's a wacky number 30. So 30 squared is 30 multiplied by itself. Now, in order to do multiples of 10 that are multiplying by itself, it's an easy way to do it. Take 3 times 3 and get 9, and add your zeros onto it. So the area, or E squared, would be 900 for this one. 40 squared, same thing. Multiply 40 by 40, or 4 times 4 is 16, and add 2 zeros, would be 1600. And 50 times 50 is 5 times 5, which is 25, plus 2 zeros. And as we can see, it is true that 900 plus 1600 equals 2500. And that's the reason why we had that question, which is question 5. Sorry, it was just question 4. Question 5 says a right triangle has side lengths. So I'm going to draw a right triangle. I'm going to put my little angle there. And I'm going to put 40, 75, and 85. Now remember, in a right triangle, your longest side is always your hypotenuse. So I'm going to put 40, 75, and 85. Sketch the triangle and draw a square on each side of it. So then I'm going to draw a square. Now I'm a little lazy. I'm just going to do that. That means a square. I'm just too lazy to complete it. What are the areas of the three squares? So if the side length is 40, 4 times 4 is 16 plus 2 zeros. That'd be 1600. 75 times 75 is a little bit more complex because it doesn't end in 0. So I'm going to go 75. Now you can go 75 times 75 and get 5625, or 75, and on your calculator you have this square button right there. So if you press that, 75 squared will give you the same thing as if you did 75 times 75. So this would be 5,600 and, was it 25 or 75? 25. And then 85 squared. 85 squared, again, you could do 85 times 85 and get this answer. Or 75 and hit your x squared button. Is that right? Oh, I did 75, not 85. 85 x squared, and you get 7225. So if we add up these two here, so if I take the two of them, so go 1600 plus 5625 will equal 5225, and it does. There's the addition statement for C. The area of the two squares attached to the legs, or 1600 plus 5625, does equal 7. Now, if it didn't equal that, what would we know about the triangle? It wouldn't be a 90-degree angle. It wouldn't be a right triangle. This might be, if it was close, this might be 89.4 degrees instead of being 90, right? But if they don't add up exactly, then the only thing you know is it can't be a right triangle, because right triangles will always have this theorem work. Question 7, the sides of a right triangle. So again, it tells us the right triangle, 9, 12, and 15. Well, I know this has to be 15 because it's the longest side. And it doesn't matter if I put 9 at the bottom and 12 there. It really doesn't matter. Again, what is the area of each square? I'm going to get real lazy and just do lines. Pretend they're squares. This area would be 81. This area would be 144. And 15 times 15 is 225. Write an addition statement. 81 plus 144 equals 225. And describe using words and symbols of relationship. So, given the fact that we said before that the legs are A, B, and C, then taking that A length of 9 and squaring it, and adding it to the length of B squared, will equal the area of the square attached to the hypotenuse, or C squared. Moving on to question 9. This time it's saying, is this a 90-degree angle? Okay, so is this 90 degrees question mark? If it is, then the ratio of the areas of square, or the sum of the squares attached to the legs will equal the area of the square attached to the hypotenuse. This is 4, this is 9, and without knowing if I didn't know, if I covered that up and said, a mystery number, what is the area? Well, this would be 13, and we know that 13 is not a perfect square, so whatever length that hypotenuse is, it would have to be the square root of 13. And if I took my calculator and said, I don't even have a clue what number square, so I hit the square root of 13, and the expected distance would be approximately 3.6, right? But when I remove that, I see that it's 4, which is not. So I can say, no, this is not a right triangle. Is it a right triangle? No, it looks like it is. But because this distance is 4 and it's supposed to be roughly 3.6, it's close. It's probably like 88 degrees or maybe 93 degrees or something like that. But we know definitively that it's not a right triangle because those two areas don't add up to be the area of the third one. This area here is actually 16, not 13. Question 10. Now we have the same question. Is this a right triangle? So the exact same as the last question. I'm going to draw something that looks like a right triangle and put a question mark there. There are 3 sides, 120, 160, and 200. The longest has to be this, and it doesn't matter the order of the other two. I'm going to place it like this. And then I'm going to draw squares onto the sides of each of these and calculate their areas. Again, 120 squared is easy to do without a calculator because 12 times 12 is 144. And then I add 2 zeros onto that because it's 120 times 120. So 12 times 12 is 144, plus the 2 additional zeros is 14,400. 160 squared would be 160 times 160, the area of the square here. 16 times 16 is 256, plus 2 zeros. We get 25,600. And the last one's really easy because 200 squared is 200 times 200. 2 times 2 is 4, and I have 4 extra zeros to tack onto here, so I get 40,000. Now, if 14,400 plus 25,600 equals 40,000, then we know that this is a right triangle. If it doesn't, then it's not. 14,400 plus 25,600 is 40,000. So yippee, yippee, yippee. This is yippee-ki-yay. This is 90 degrees. So therefore, we know it is a right triangle because the area of the squares that has the legs do add up to be the hypotenuse. Again, same thing with question 11. I'm going to draw my triangle. I'm going to place a question mark there. The longest is 8, so I'll put it where the hypotenuse would be if it's a right triangle. I'll put a 5 and a 6 here, and I'll determine whether or not this is a right triangle. Attach the squares to the side. These are rounded squares. Put the areas of each square inside there. That's 25, that's 36, this is 64. Does 25 plus 36 equal 64? No, it does not. It's close. It's 61, which means it's close to 90 degrees, but this is not a 90-degree angle, and therefore it's not a right triangle. Question 13. There's a picture of a person who made a triangular garden. For whatever reason, they made a triangular garden. And they wanted to know, is this going to be a 90-degree angle? Because, of course, the daffodils or whatever they're growing in their garden can't grow unless the degree is at 90 degrees. The garden is at 90 degrees, so they have to see. So, if 4,800 plus 4,800 equals 9,800, then we know it's a right angle. And when we take our pencil and paper and add these up, we get 0, 0, 16, 9. I get 9,600, which is not 9,800, which means this is not right. So it's not a right angle. A lot of people have trouble with 15 simply because they're like, well, there's only two numbers. There's not a third number. How am I supposed to know what the third number is? So if I take this and rotate it, I have a beautiful right triangle. Okay? Now this picture right here, this thing right here is a tape measure. Some people didn't know what that was. And this little yellow thing here is the tape measure itself, measuring the diagonal. So we don't know the length, but we know that this is 8 and this is 6. Okay? And the tape measure said that it was 9.5 meters. That's what he measured. So I'm going to take that 9.5 because it says they measure the diagonal as shown to be 9.5 meters. Most people can't read that, so they were like, I don't know what it is. But now that we know that, we can placez-vous our squares on here. That's 64 meters squared. That square that would be attached to that imaginary square. This would be 36. And 64 plus 36 is a nice, lovely 100. That is 100. And since I'm pretty darn sure 9.5 times 9.5 is not 100 because it should be 10 meters. So if this distance here was 10 meters, then we would know that this is 90 degrees. But because it's only 9.5, they're close, but it's not 90 degrees. Is it the angle 90 degrees? No, it's not. Badip is building a wooden box for storing the colored pencils. The box will have rectangular sides that are 12 centimeters wide and 20 centimeters long. Show how we can measure the sides of the rectangle without using a protractor. So here's the box he's building. And it's 20 centimeters long by 12 centimeters long. And we want to know, he wants to make sure that this is exactly 90 degrees. So if he has that as exactly 90 degrees, we can redraw on paper the diagonally cut out part of his box. And we can say if this was the box and this was 20, the expected distance from corner to corner, we can calculate what we would expect that to be if this was a 90-degree angle. The expected distance of that, this would be 400. This would be 144. The area of this square attached here would have to be 544 centimeters squared. So the distance from here to here would be the square root of 544. So if I take 544 and press the square root button, what number times itself is 544? It's going to be approximately 23.3 centimeters long. So if he took a measure of the corner to corner of the box and it was roughly 23.3 centimeters, then he knew it's roughly 90 degrees. If the diagonal was only like 21.7, then he knows he has to open this up a little bit more until he has that distance of 23.3, at which point he would have his 90-degree angle. And the last question, it says a right triangle has a square attached to each side. So a right triangle has a square attached to each side. Well, I can draw that. That's easy to do. That's more of a circle, but whatever. Two of the squares have areas of 10 centimeters squared. So I'm going to write that in red. 10 centimeters squared. And one of the other squares has one of 15 centimeters squared. What are the possible areas for the third square? So one of the possibilities, it is possible for this to be one of the things. And if this was it, the area of this one would be 25 centimeters squared. That is one possibility. So one of the possible areas for the third square is 25 centimeters squared. But it is possible that this was the setup. And if this was the setup, then this here would be 5 centimeters squared because 10 centimeters squared plus 5 centimeters squared is 15 centimeters squared. So one of the other possibilities is that the other square was 5. And somebody in the other class said, well, isn't it possible, isn't it possible that this could be here and this could be here? Is this a possibility? How come? Because the hypotenuse of your triangle always has to be the biggest, which is impossible to have this leg be bigger than this leg because otherwise it's not a right triangle at all. The hypotenuse always has to be. So the answer to the question is the third square could have an area of 25 centimeters squared or it could have an area of 5 centimeters squared.